Hi, welcome to this webinar hosted on Zoom. I'm joined with my colleague, Michelle Sachdev, the director of the Illinois Maker Lab, and Morgan Sterling-Saletta, who is on the faculty at the University of Melbourne. Morgan, thanks for joining us today.
No, thank you for having me, Eric and Michelle.
So what time is it down there in Australia?
It's 8 o'clock and it's a wet winter's day here. We're just heading up to winter solstice. You guys are heading into summer.
So 8 o'clock a.m.
That's right.
You look very alive and awake for 8 a.m.
It's a Saturday morning too. I normally wouldn't be this awake yet. I had a strong coffee.
Well, we appreciate you taking time out of your Saturday morning to join us and talk about, I think, an area that we all have mutual interest in, 3D printing.
Great.
Right. So perhaps you can tell us a bit more about yourself and how you became interested in 3D printing and the sort of things that you're doing. I know you're writing articles about the topic, but just tell us your 3D printing story.
Okay. Well, actually, I mean, this is, we're going to talk about 3D printing in space, I think, and I think I've been a space enthusiast for most of my life. I grew up next to NASA Ames, had a chance to tour the facility as a young kid on multiple occasions. So I think that really sort of boosted my interest in science and technology and space. And more recently, I've seen what's going on with 3D printing, and especially with regard to, I think, what it's going to enable in terms of what we can do in space is really, really interesting. My background's in science and technology studies, so this kind of thing is really our bread and butter. And there's a lot of 3D printing going on at Melbourne. I'm sure you guys have a maker lab as well, really interesting one. So yeah, there's a lot of opportunities to see what's going on, I think, with this new stuff.
And you mentioned Ames. I assume you meant Ames, Iowa.
Oh, NASA Ames in Mountain View.
Mountain View. Oh, Mountain View. Okay, I was thinking in the Midwest, Ames, Iowa. I didn't realize NASA had something in Ames, Iowa. I guess they don't. So
oh yeah, there was a NASA Ames research facility at Moffett Field.
Yeah, so in California.
Yeah, that's right.
California. Yeah, we don't, Vishal, we don't get out that way very often.
We don't.
Sometimes we are adventurous. We move from Champaign to Urbana.
I know. Yeah. That's an adventure.
Well, Vishal, I think, is in North Carolina as we speak.
I am. Yes, I am.
And I'm here in the Orange Room here in.
Yes. We need some blue in that room.
That's right. So Morgan, you wrote this interesting article in an online magazine called The Conversation, called "Want to Build a Moon Base Easy? Just Print It." Although it's probably a bit harder than you make it out to be.
The editor made that sound a little bit easier than it was.
Well, it's a very attention-grabbing title, and. Yeah. Here you actually outline a number of different space-related initiatives. One thing that we're familiar with in Maker Lab is I guess now it's almost 2 years old, the wrench that was printed on the International Space Station, which is also available on thingiverse.com. And we printed one out here on our 3D printers. But the one thing that really fascinated me about your article was this idea of a Mars Icehouse.
Yeah.
We have these future colonists on the planet Mars who are making their residence using the ice and taking this material and 3D printing it into a livable structure. Can you say a bit more about this, this amazing concept?
Sure. So that was the award-winning project, I think, of Print Your Own Habitat. I think that was the title, a NASA competition that was run last year. That was done by Cloud's Architecture Office and their space exploration group. Yeah, and I think that's one of the most revolutionary projects I've seen. in fact, it's a little bit more complicated than just using water, it turns out. They have to mix it with an aerogel, and they need to use a plastic shell. Mars is low atmospheric pressure would result in the ice just sublimating, I think. So it turns out it's a little bit more complicated. But they've actually, if you go to the website, we can post a link, I think, to the forums. They have a video showing a project here on Earth actually printing with water. So they did a demo project printing the shell. And there's a lot of advantages to that. I mean, normally when we think of Mars bases, we've thought of having to bury the structure, essentially to protect the astronauts from radiation levels. But water is a really good insulator, both for heat and for radiation. And it lets in light. So it's this really different structure, I think, than the projects that we've seen in the past that sort of make bricks out of Mars dust and bury a structure in this in a cavern somewhere. So the idea is revolutionary, but it's also just a beautiful piece of in terms of an architectural project. They did a demo, they printed out of ice. It's something I'd never heard of. Really original idea, I think, and quite a beautiful structure.
Now, if you see the article, it's a very small photograph, but it's quite striking. It's almost cathedral-like nature. And I think this example highlights one of the advantages of 3D printing, and one of the things that Michelle talks about in his class is the idea that it allows you to create designs that you couldn't do before, and vice versa. Designing for 3D printing is very different than designing for conventional manufacturing. I don't know if you have any thoughts on that topic.
Well, it's true. I mean, I think, in terms of, we're starting to see some really revolutionary things in architecture, I think, and manufacturing generally. I've got a bit of an architecture fetish, really. So I'm quite interested in the architectural side of it. And yes, it allows us to do things with materials that we haven't used before. But it also, what we're seeing, I think, really interestingly, is a return to sort of some traditional materials, things like clay and earth. People like Enrique Dini, who's featured in a movie, The Man Who Prints Houses. He's working with mud and clay, artificial rock, printing in ways, and it allows us to build structures and shapes that we wouldn't be able to build normally. But we're also seeing a sort of a mix of traditional materials. And with the Icehouse, it's interesting. You think, Mars is probably this, the most extreme environment that you could imagine other than outer space, really. But if you think, here on Earth, the Arctic is one of the most extreme environments. And, for thousands of years, what's been allowing people to live there are ice structures, igloos that keep in the heat. That allow people to survive in a really extreme environment. So there's some really interesting back and forths, I think, that we're seeing here.
Interesting. Is there anything else in your article or elsewhere about printing in space that you find especially interesting you'd like to talk about?
Yeah, well, I think, so, one of the things that people have been talking about, and, we've known about since, at the turn of the 20th century, so long before the space program actually really got started, the Russian scientist Konstantin Tsiolkovsky predicted that if we were going to start colonizing the solar system, a requirement for that would be able to use the resources out there, basically in situ, in place, things like asteroids or rocks on Mars or the moon. And I think 3D printing is something that's really going to enable that, the ability to, we don't have to launch the materials to build things from Earth, which is expensive. We can actually go out there eventually, go to an asteroid with a small manufacturing robot that's got 3D printers on articulated arms, and processing units that take the asteroid as a feedstock, digest the metals from the asteroid, and then through various additive manufacturing processes, maybe something like laser scintillation or something, 3D printing, build a structure, build a spacecraft. Maybe something like a Mars cycler or something that Buzz Aldrin's been talking about for a long time, that going back and forth between Earth and Mars in order to keep a permanent manned presence out there. But probably more immediately, I mean, that stuff I'm interested in it because I like this sort of futurist science fiction element to it. But in the more immediate term, the things that we're seeing on the space station, we've got the company Made in Space that built the printer that you spoke of earlier that made that wrench. They've teamed up with the home improvement company Lowe to provide more 3D printers for the ISS. And really, I think what we're seeing there is there's an Archinaut project that's been funded by NASA as part of their Tipping Point Technologies program, where they try to fund technologies that they really see as being the tipping point of providing something revolutionary. They're going to attempt to build a satellite antenna, or part of a satellite antenna, using robotic arms that are provided by a company called Oceaneering Space Programs, teaming up with Northrop Grumman to provide the control systems, to actually build a structure outside of the space station. So in this case, what we'll be able to do is build large structures that we don't actually have to launch within a spacecraft. We'll just be able to send the feedstock, manufacture part of a satellite in space. And that's, I think, in the near term, that's what we're going to see in terms of really revolutionizing the space technology and the space program. Parts of satellites being built, tools on the International Space Station, et cetera.
Yeah, and it's I think an amazing possibility. What you seem to describe in this longer-term vision of harvesting an asteroid makes me envision a 3D printer almost as a parasite.
Yeah, that's right.
Yeah.
Never thought about it in those terms before, but it's fascinating. So you don't, not only do you not need the finished products, you may not even need the raw material, right?
That's right. Yes.
So it'd be like a 3D printer here in Champaign printing out of corn, right? The cornfield. And
Yeah, I mean, I think if you remember what I forget, one of the speakers in one of your courses was Hod Lipson. How am I forgetting the name? He was talking about molecular assembly as the next frontier. So there, you're not even restricted to the kind or sort of the physical shape of the raw materials. You're just working with molecules, and that might be the next stage where single or sort of a fixed set of molecules can be used to create multiple objects.
Yeah.
So I think
possibilities are just amazing. This question of almost everybody that I interview in this domain: what is the future, the short-term future of 3D printing 5 years from now here on Earth? Let's stick with Earth, not space for the moment. What we see in 5 years from now, a 3D printer in every home. What will this desktop 3D printing space look like, in your opinion?
I'm not sure we'll see a 3D printer in every home. Perhaps every home that wants it. I mean, I have a number of friends that have 3D printers. We've 3D printers are sort of open access here on campus. I think certainly in a lot of countries we'll have 3D printing facilities in easy access to anybody. So you'll be able to, if you have a design, send it away, receive, maybe by Amazon or something like this, get the printed object, or go to the local library or a local community center. And certainly people will have 3D printers in their homes, perhaps not every home, but I think in 5 years' time we'll start to see a lot of 3D printed homes, cars.
Yeah, I just saw one last week when I was in Knoxville, Tennessee, at the soon-to-be opening Local Motors Knoxville plant, where they're 3D printing car bodies, and they just announced a 3D printed, automated, self-driving, electric-powered bus.
Wow.
You think about all those things: electric-powered, automated, 3D printed, right?
I'll wait for the self-driving thing to get a little bit better before I buy a ticket for that bus. But
the only thing they forgot was the popcorn maker, right? Would have been the perfect electronic device. Michelle, do you have any questions for Morgan?
Actually, my question was pretty similar to what Nagarajan has just asked. He's from India. It's 3:30 there, and he was there on the earlier Hangouts as well. So he seems a committed enthusiast. So I'll state his question. I mean, I was curious, the lack of gravity, how does that change things about printing in space compared to printing on Earth?
Certainly, I think with some additive techniques, it really will change things. The made in space printers that they sent up in 2014 to do that demo project, that was really sort of to test whether or not filament extruding modeling would work in microgravity, it seems to work just fine. I think probably because of the actual material properties of the plastic and the fact that it's viscous and sticks together helps it. I think with perhaps some other technologies, they'll have to come up with some really innovative solutions, maybe with things like laser scintillation, where you're trying to fuse metal objects together out of a metal powder. That might be more problematic. But with the filament extrusion, it doesn't seem to be an issue at all.
Okay. Okay.
I would think also if we had an enclosed build envelope, if it was enclosed and in a vacuum, that should be less of an issue. So if it's like an Ultimaker or MakerBot that's open, that could be problematic. But if you look at, for example, the big additive manufacturing printer that Locomotor uses to make their cars, that's an enclosed space. That is that I think perhaps might. I'm not sure. I don't know enough about gravity. If that would fix the gravity problem, I guess you could create. Vishal, you're the scientist. What do you think? Would an enclosed space solve the gravity problem, or is it just?
This sounds. We need a trip on the vomit comet to test this. Right. This is our ticket to ride that.
Yeah.
And we need to do something like that.
Yeah.
So Morgan, I'm not familiar with your background. What all is happening at your university in terms of 3D printing?
Well, in short, a lot. The architecture program has a sort of a maker lab or a fab lab sort of thing. It's actually open access, so it's primarily for architecture students, but anybody can go over there. Take a short course essentially to allow them to use the facilities, but then can start 3D printing. I work with a program here, the Melbourne Space Program in the School of Engineering, and that program is working on building a CubeSat, so a small sat. So this is essentially a student-led project, and we're 3D printing the body of that. The engineering department, of course, is very interested in, and I don't know everything that they're doing with it, but it's certainly, most people are extremely interested in the possibilities, and not just for consumer items or small parts, et cetera. I mean, people are really looking at big projects, civil engineering projects, bridges, things like this, that we'll be able to 3D print in the future.
Actually, it's interesting you mentioned that the CubeSat. We're doing something quite similar here at the University of Illinois. Perhaps Rishal, I'd like to maybe talk about that.
Sure. Yeah. So Eric and I were on a grant with the engineering school and another university as well. So it's it's an innovative grant that NASA gave out from the education perspective, where the engineering units are building a CubeSat, or actually it's actually 3 different components that they're building, and then they brought in business for the project management and collaboration expertise, and journalism students as well from another university to bring in the sort of putting this out as to the work that the students are doing for the general public, and managing the publicity around it. So we got that grant recently, and we're waiting for for NASA to dole out the funds before we start working on that.
And then we're hoping that we'll be able to use our lab to 3D print actual part of the satellites.
Yeah. Yeah.
So soon we'll have our products in space, which would be really cool.
Yeah, and how exciting! I mean, I think that kind of project. I mean, firstly, NASA's been really great with this sort of public-private funding and really promoting getting these kind of things going. But I mean, how exciting for students to be able to participate in a program like that, to really show them that there's actually something concrete that you can do that's exciting, that's visionary, that's futuristic. Hey, it's just a small satellite, but it's a satellite, right? It's going to go into space.
I think it's a great example of how 3D printing opens doors for people, how it's opened doors for Vishal and myself, and how it can open doors for our learners, throughout the world. Because I'm a marketing professor, and I wouldn't have had a chance to be involved in NASA grant if it wasn't for 3D printing. And how cool it's going to be for most business school students don't have that on their resume, a NASA project. Our students will have that possibility because of the lab because of 3D printing. And I'm sure that our learners will have similar stories if they pursue this domain of interest.
Yeah, I think so.
No, I agree.
We have one more follow-up question from Nagarajan talking about using conductive inks, in a zero gravity context. Do you know if that's even possible? Has it been tried?
I'm not aware that it's been tried yet. I think they're still working with to the best of my knowledge, they're still working with sort of single materials, largely plastics. And I mean they're taking this nice and slow, I think, with the International Space Station. But I mean, certainly, as you guys are well aware, I mean, when we really start to see the use of multiple materials being laid down, I mean, in terms of electronics and lots of I think there are lots of applications there that we'll see that are really, really interesting. And probably some of these maybe hybrid manufacturing techniques where we start to see 3D printing with 3D weaving and the use of composites and composite structures, some of which are printed, some of which is woven. I think that kind of thing is going to be really interesting to watch in terms of things like automobiles, aircraft bodies, trains, etc. These kind of larger structures.
Yeah. Just one last question. A question about you. So, where do you see your 3D printing adventure taking you? What's next for you in this domain? Do you plan to keep on writing about 3D printing? And assuming that you have an interest in architecture, an interest in 3D printed buildings, and all of that happening all over the world, right? In China, in Amsterdam, Dubai, different spots. So what's next for you? Where do you see your interest headed?
Well, if I were going to say where I'd like it to take me, I'd say I'd like it to take me to space. But that's been a long-term dream. But I think in terms of what I can do as an academic, I think it's more in terms of entrepreneurial marketing and science policy. I think there's a lot of, as you were saying, there's a unique opportunity, I think, for 3D printing and these emerging technologies mixing with new business models to really come together, I think, in really interesting ways, bring people from all kinds of interdisciplinary backgrounds in projects that, today we're only really just beginning to imagine. I think the future is really open in that regard, I think, for all of us, really.
I agree. So would you say 3D printing is an evolution or a revolution?
Both. That's a hard one. I was thinking in terms of an evolution. I was thinking of termite structures, and in some ways we're really only sort of rediscovering or discovering now how to do things that nature's known how to do for a long time. You look at those termite mounds, and it's really a sort of all these little termites. We could imagine in the future robots that can build these structures for us. In much the same way, but certainly revolutionary, I think, in terms of what it's going to allow us to do in the future.
There is a really good point. There's our favorite book, a book that we recommend in this domain, 3D Printing Will Rock the World, by John Hornick, has a nice chapter in that book about biomimicry, 3D printing, and how 3D printing can really influence, allow us to create biomimetic shapes and creations that we wouldn't be able to create otherwise. So I think you're right. There's a strong link between Mother Nature and this new advanced manufacturing technology. They're closer than we might think.
Yeah.
So that's a good way to end. Morgan, thank you for your time.
Okay, thank you, Eric. Thank you, Vishal.
Thank you, Morgan.
Students for the questions.
And next time your travels take you to Champaign or Urbana, be sure to stop by the Illinois Maker Lab, and you'll be able to see our new T-shirts.
Nice.
It was designed by our guru, Kevin, but we're happy to send you one. If you send me your address, we'd be happy to send you one.
I'll happily wear it. Thank you.
Sure.
Okay, thank you, Morgan. Thank you, Michelle.
Thank you to all the viewers as well.
Yeah, thank you, guys.
Thank you, Daniel, Carlos, and Nagarayan, and everyone else for joining us. We'll see you next time.